Hello everybody. This time I am going to talk about truss. You know that truss is a very common topic in FE Civil, and in classes you did solve truss, but let me do something else. What is truss first? So truss is a pin connected members. So pin. So say this is a truss. So you can see here this is a member, another member, another member, another member, another member. So here 1, 2, 3, 4, 5. Here 5 members. They are connected by pin. Yes, pin joint. So in truss all the joints must be pin. Number one. Number two is there cannot be any load on the member. That means here we cannot apply load. No, we cannot apply load on the member. We can apply load only at the joint, here or here, whatever it is, only at the joint. So that is the definition of truss. Now what happens if we apply load in the member? Then it will be frame. Moment will develop in the member. So that must be solved using frame analysis. So all the theory for truss is valid if all the joints are pin and loads are only at the joints. In classes you learn that we can solve truss in 2 ways, or somebody learn 3 ways. Let me summarize that. So solving, you learn that truss can be solved using joint method, then section method. So these are the 2 methods you learned in your classes. Now there is another method. Obviously you heard about it, but you did not pay attention to it. But that method is, I named it shortcut. So today all of my discussion is based on this shortcut method. So shortcut, why it is important for FE exam? Because in FE exam time is limited. For every questions you will get roughly 3 minutes or less. So every question is very short. Now during this using this method, sometimes you can get the answer. Even my experience shows most of the time the question from truss comes from this method, shortcut. Now what are the shortcut? So here we have 2 ways. Number 1 is zero force member, and number 2 is I named it say same perpendicular. So what are the 2 shortcuts? One is zero force member, second is same perpendicular. Maybe you never heard about it because I just named it. Yes. So now we will see what is zero force member. For zero force member we have 2 rules. So zero force member. So zero force member. So we have 2 rules. What are the rules? So rules number 1, 2 members form a joint then no load, both members are non-linear, then both are zero force member. What does it mean? It means 2 members form a joint, no load in the joint, and both are non-linear. Non-linear means it is not like this. It is either this or this or this. So it should be non-linear. Then both are zero force member. That is rule number one. Rule number two. So rule number two is three members form a joint, no load. Okay, right here form a joint. Obviously no load. Two members linear. Third one is zero force member. So what we learn? Zero force member, two rules. Rule number one: two members form a joint, and no load, but not linear, inclined like this, or this, and no load. That both are zero force member. Then this rule: three members form a joint, no load here, no load. Two members are linear. Then third one is zero force member. So it can be this, can be this, can be this. So three members form a joint, no load, two are linear, third one is zero force member. Now we will see some example on it. Say assume this is a truss. Here all members are pin connected, loads are only at the joint. That means it is a truss. Now here we need to find the zero force member. What are the zero force member? There might be 1, 2, 3, 4, whatever, many. There might be many zero force member. Okay, what we learn? Two rules. Rule number one: two members form a joint, no load, both are linear. Sorry, both are non-linear. Then both are zero force member. Then rule number two, excuse me. So rule number two: three members form a joint, no load, two are linear, third one is zero force member. Okay, come one by one. Say two members form a joint, no load, both are non-linear, so both are zero force member. So these two members are zero force member. So simply we can delete it. If we know that this member is a zero force member, we can delete it so that our task looks easier, simpler. We can solve it easily. Then once it is done, is there any other member zero force member? Here, once I delete it, only two members. Member 1, member 2. This is no longer available. Two members form a joint, no load, but there is a load here. This is a reaction. So we cannot decide here. Here, three members form a joint, load. So we cannot decide from here. Here we have a load. Here, one, how many members? 1, 2, 3. So three members form a joint, no load, two are linear, third one is zero force member. That means this is also a zero force member. So in this truss we found that 1, 2, 3. 3 are zero force member. Now we will see another example for zero force member. This is not a good color. Okay, this is another truss where all the members are pin connected and loads is acting only at the joint. So as another load is here. Okay, in this test we will find the zero force member. So two rules for 2 members form a joint and 3 members form a joint. So 2 members form a joint, but there is load. Here we have a reaction, so we cannot decide from here. I'll delete it. Here we cannot decide. Here 1, 2, 3. 3 members form a joint, 2 are linear, no load, third one is 0. So this is a zero force member, 0. Here many members, so we cannot decide here. 1, 2, 3. 3 members form a joint, but no load, 2 are linear, but here 2 are not linear. So we cannot decide from here. Here come, here 3 members form a joint, no load, 2 are linear, third one is 0. So this is a zero force member. Once it is a zero force member, we can delete it if we like. So is there any other member, zero force member? So this or no, because we have a load here, here no. Now you can see here. If I delete this member, because it is a zero force member. If I delete this member, what is happening here? 1, 2, 3. Now I have only 1, 2, 3. 3 members form a joint, no load, 2 are linear, third one is 0. So this is actually a zero force member. So we found 3 zero force member here. Now you may be confused by seeing the load here. We have load here, then how it can be zero force member? Yes, if we consider this joint, we cannot decide. But if we consider this joint, we can decide. But to find zero force member, for this, is it a zero force member or no? We have to decide first why this is zero force member. Then if we delete it, we have 3 members left. So sometimes directly you cannot find a zero force member, but once you find one zero force member, it may give result for another member. Okay, let us see one more example. So this time assume a signboard type vertical truss. Okay. Say this way. So one more truss. Okay, all the members are pin connected. Let us assume load here. Maybe here, maybe here. So in this truss, we will try to find zero force member. So find it. One joint, 2 members form a joint, no load. These are not linear, so both are zero force member. So this is zero force member, zero force member. So this is done. Simply we can delete it. Our truss became very simple. Now if we take this joint, 3 members form a joint, 1, 2, 3, 3 members form a joint, no load, 2 are linear, this is zero force member. So this is zero force member. We can delete it simply. Now if you see this joint, you might get confused because there is a load here. How it can be zero force member? But it is. If we take this joint, we cannot decide. But if we take this joint, we know it is zero force member. Now, by applying different rules, your joint method, section method, whatever you apply, you will get this member is zero force member. So method doesn't matter. Whatever method you follow, you must get the same answer. Okay, then let me show you the other shortcut. At the beginning I told that shortcut 2 methods. So again write shortcut. So one shortcut is zero force member. Other shortcut I named it same perpendicular. Same perpendicular. You never heard this name because few minutes ago I gave this name. It is not a book language. I just named it. So we will see some example. Same perpendicular. Just memorize this. Say azimuth truss, the most common truss in our daily life. You saw this kind of truss in many places. So all the joints are pin. Again, if the joints are not pin, it is not truss, it is a frame. So all this discussion will not work. Okay, apply some load. Say here, maybe some load here. Now, same perpendicular means, okay, maybe some load here, some load here, many loads here. Same perpendicular means the force is acting along the same direction of the member. Force is acting, okay. So say this force is acting in the same direction of this member. That is, I name is same. Perpendicular means the other members are perpendicular to this force. The other members are perpendicular to this force. That means this angle is 90 degrees. Then whatever the value of this force, say 2 kips. Then the value of the force in this member is 2 kips. Directly, without any solution, any joint method or section method, whatever, we can tell that this member is taking this load. Now, it is true only if the force is acting along the same direction and other members are perpendicular. For any reason, if there was another member here, then this rule will not work. This rule will work only for 3 members. 2 are perpendicular and the other one is same direction to the force. Similar here, say this force is 3 kips. This member will take all the force. Why? This same direction and other members are perpendicular. This is 90 degrees. So the member force here is 3 kips. The member force here is 2 kips. That is, I named it same perpendicular. If you take joint method, if you take this joint, you will see it. Say this joint. If I draw this joint here, it is similar to this. This is 2 kips, one member, other member. Say force here is F. You can see here, if we apply summation of Fy is 0. So F is upward, say upward. 2 is downward, assume downward negative, upward positive, equals 0. You will find F equals 2 kips. Without applying the joint method, simply by seeing it visually, you can tell it the member force. Okay, another example. Say a signboard type truss. Say this truss, I have a force here, 2 kip, force here, so 4 kip, force here, say 5 kips, force here, say 1 kip. Then you can see here, if I take this joint, many members, so this force is in the same direction of this member, but I have 2 more members, so I cannot tell it. Here, this is a roller support, so my reaction is this way. So I can say if I take this joint, this force is in the same direction of this member, and others are perpendicular. So this member is taking 1 kip. I can directly tell it 1 kip. Now it is acting towards the member, so it is negative. So compression. Here, if I take this this point is joint, The force is acting in the same direction of the member. Others are perpendicular. So same perpendicular. That means this member is taking 4 kips, but it is towards the member, so compression. Again, to clarify, the member is here. If the force comes towards the member, it is compression. If this is a member, if force goes away from member, away from member, then it is tension. Towards member, compression. So if this is my member, if the force acts towards the member, compression, away from the member, tension. So we discussed 2 methods, zero force member, and I named it same perpendicular. Now my experience shows in FE exam you might get at least 2 questions, but there's a guarantee that you will get at least 1 question from Truss. If you get 2 questions, 1 question will be for sure from zero force member or this shortcut to same perpendicular. If you get 1 question, there is a good chance that that question will be from this method. If you have more question, please you can see my website apbriefs.com. In this website you can practice more problem, and in my next video I will discuss about the joint method and section method. Okay, see you then.